All right, so today is 1-3, and we're dealing with linear models, okay, and modeling with linear functions. In other words, if you remember back to previous years, and maybe in science, when you've dealt with lines of best fit, trend lines, when you've dealt with scatter plots, that's kind of what we're going through today. So as we go through this lesson today, these are things you may end up defining. And if you try to remind me at the end of class, I'll tell you a cool deal about a calculator, about the graphing calculator. Just help me remember at the end of class. Something that will help you out. So some core concepts. This is in page 15 of your student journal. Given m and the y-intercept, when you're given the slope and the y-intercept, usually writing an equation of a linear function or a linear equation is pretty easy. We just use y equals mx plus b. Remember, b is your y-intercept and m is your slope. Okay? If you recall, there are different names for slope. Okay, we call slope m. We call it change in y over change in x, and we use a little delta symbol for that. And then there's a slope formula. If you remember, remind your neighbor what a slope formula is. Well, let's see if you got it. It is y2 minus y1 over x2 minus x1. Now, usually you won't see those parentheses, but I put them in there just because if I had two coordinates and I actually wanted to find the slope of that line, so for instance, maybe I have a coordinate of -2, 3, or -2, -3, let's use. Okay, and let's say a coordinate of 1, 4. Okay, so that's this coordinate. I guess I could have been a little more specific there. All right, if I wanted to find the slope of that line and I didn't actually have it graphed, what I could do is I could say, well, I need to find the change in my x values. So if I actually put an x and y axis on this, probably not the best XY axis, but that'll do. Okay. Yeah, it would, but are you going to survive? No. Okay. Well, I don't know what to tell you then. You guys are going to have to. You're going to have to survive. Here, we'll make the dot a little bigger. All right. So there we got it. So if I go from change in x, I'm trying to find this distance right here, from that point to that point. I'm using this as my measuring stick, which really means I'm saying, well, how far from -2 to 1? Once again, obviously not to scale here. But this length is? It's 3. Okay? So really that's what you're doing when you're using this formula in here. The change in x is saying I'm going from -2 to 1. Okay, now actually when I do the math, that gives me -3. But that's no big deal, as you're going to see here in a minute, because distance is always positive. But if I am going change in y, that's from here, -3 to +4. Okay? So I'm figuring that distance. So -3 to +4 is how far? 7. So I'm going -3 minus 4, which is -7. You'll notice they both change to positive. We get the same slope of 7/3. Okay? That's how the slope formula works. Really, you're finding the change in the x values over the change, or the change in the y values over the change in the x values. Okay? The other way to think about it, for those of you who recall, we used to, or if you have a picture, you could actually just do rise over run. You rise this much, you run that much. You draw the little triangle in there. Okay? Who remembers doing that? All right, so here my rise is actually my change in y. And my run is actually my change in x. Same idea. Okay? All right, the other thing that we have that a lot of you might not be familiar with because some algebra teachers don't teach it is point-slope form. And if you're given a slope and a point, you can write the equation in point-slope form. Okay? The way that would work is I would maybe say, hey, the slope of a line is 1/2. this will go up here. Okay, the slope of the line is 1/2, and it goes through the point 3, 4. So write the equation of that line. And what you could do is say, okay, that's x1 and that's y1. And this is my slope. So I'm going to replace x1 in my equation with 3, y1 in my equation with 4, and m with my slope. So that equation now reads as y minus 4 is equal to 1/2 times the quantity x minus 3. Now sometimes you will keep it in this format. You'll see it in that format left like that a lot because that is point slope form. However, you could also change it to slope intercept form by just doing the math here. So 1/2 x minus 3/2 equals y minus 4. Add 4 to both sides. You get y equals 1/2 x minus 4 is also the same thing as 8/2. So that would be 5/2 there. Okay. You would end up adding 8/2. Oops, that would be plus 5/2 though. Okay. So either format usually works there unless it's specified you need to go one or the other. Okay, so that's a really quick review. Any questions there? All right, very good. Finding the line of best fit, we're going to actually go through that here in a while, but that's on the next page. There's obviously a place for you to take notes if you'd like later. We're going to skip past that for now, and I want you to go ahead and take a look at your note page you picked up, and we're going to try some problems here. This is the monitoring progress. Remember, here's your title. We're 1.3. Here's our learning goals. I want you to try monitoring progress number 1. This is not in your student journal, remember. Yes? Those note pages right there? Yeah. All right. There we go. So you guys get about 2 minutes to work on that. Give it a go. You work with your groupies. Hey, can I have your attention, please? Thank you. Well done. Hey, the graph shows the remaining balance y on a car loan after making x monthly payments. Write the equation of a line and interpret the slope of the y-intercept. So what is our y-intercept? So in order to write an equation, you need to know the y-intercept and the slope. So m and b. So where does it cross the y-axis? 18. So the cost of our car is 18 bucks. Oh, in thousands, yes. That would be tough if you had an $18 car. I don't know if I'd want to drive. Okay. What's our slope? Anyone want to tell me how they found the slope? Yeah, the change. I drew the triangle in my head. Yeah, you draw the little triangle, right? You could actually use the formula if you wanted. You could actually do y2 minus y1 over x2 minus x1. However, when you have a picture, the triangle's nice. So, first of all, is the graph rising or falling from left to right? Falling. So that means it's a negative slope. Okay? And then when I'm falling, I'm going down how much? 3. Look at your scale. Make sure you're checking that. Going down 3 and over 10. Negative 3/10. So my equation becomes y equals mx plus b, or y equals negative 3/10 x plus 18. Is it okay to leave it like this, even though it says in thousands? I mean, really, when I say I'm going down 3, I'm really going down 3,000, right? Okay? It's okay to leave it like this as long as you realize when you plug things in like this, 36, that deals with number of payments, so 36 goes in for x. When I do that and I actually do the math, I believe that gives me y equals 7.2. I think. Is that what you guys got? No. No? Yes? Okay. Now, 7.2 doesn't mean 7.2 payments, right? That's like right here. And that definitely, or I'm sorry, 36 payments. 36 payments is like right here. And when I go up, well, 7.2, that's not 7.2. It means 7.2 thousand, which is 7.2 times 1,000, or 200. Yeah, you got to multiply by 1,000. Okay. Let's interpret this here. Interpret the slope. What does slope mean in this one? Look at your labels. Y over x. What is my slope telling me? The balance over payments, right? So, what does 3 mean? I'm decreasing 3,000 for every 10 payments, which means how much am I paying a month? If it's 3,000 for every 10 payments, what's my payment? $3,000 per 10 payments. 3,000 divided by 10 is $300. Your payment is $300 per one payment. How many of you are paying $300 for your car? Making your car payment. All right, some of you are like, I don't even have a car. Okay. All right. That's interpreting the slope. You're saying, hey, it's $300 per payment. Okay, what's the y-intercept telling me? Hey, volunteer, y-intercept. Yeah, Chase.
The number of payments that you have to pay out, like how many times you're gonna have to pay it.
Not quite. Y-intercept, right? How much? Good. How much your original cost of your car was? In this case, $18,000. Okay. Hey, any questions? Okay, here's what I see. I see about 20 of you or so. I'm not counting. Like completely engaged, taking notes, following along with the problem. I see about 5 of you talking to the people around you, and it's funny to watch those people try to ignore you, or some actually talking to you. Those of you that are talking, you remember that it's not just you that is not learning, it's the person you're talking to, and all the people that are around you that are having to listen to you, even though they don't want to hear you. Okay? If you're talking, I'm going to end up sending you out of class here in a minute. Okay? If you're staring off into space because you're like in a food-induced coma from just eating, all right? If that's you, please have your neighbor remind you by like bumping you every once in a while. Don't like punch him or anything, but just help you to stay focused. All right, here we go. Example 2. This is example 2 out of your book, so your main idea, example 2. 2 prom venues charge a rental fee plus a fee. You guys can read that. I want you to do example 2. You get a couple minutes to work with your groupies. All right, 2 prom venues charge a rental fee plus a fee per student. The table shows the cost for different numbers of students at Lakeside Inn. Okay, the total cost, Y in dollars for students at Sunview. So we have Sunview and Lakeside, but at Sunview is Y equals 10x plus 600. Which venue charges less per student? How many students must attend for the total cost to be the same? So you're trying to make the cost of Sunview equal the cost of Lakeside. Now, they tell you the cost of Sunview. We could think of it this way. Y sub 1 is equal to 10x plus 600. The cost of Lakeside is represented by this. It'd be nice for them to actually label that, but they tell you it in the problem there. Now, if I want to actually figure out the equation for this, I'd have to find M and B. Any idea how to find M using the table? Chase?
So like in like the 125, so that goes up to 25 on the x side, so it'd be on the bottom, and then it would be 300 on top because it goes up by that, and so then you reduce and it goes to 12.
Okay, so let me pause for a minute. So he's saying the change in Y over the change in X is 300 over 25. Is that correct? And you reduce that to 12. Now, is that hold true the whole way? Is it always 25 and always 300? Yeah, it does. It is. That just tells us it's linear. And that's good. Okay. Very good. That's our slope. Nice job. How do we find the y-intercept? Emma? That's pretty good. Everyone see that? So she's saying, hey, if it's linear and I'm changing 100 this way, and that change gives me 1200 here, then I could essentially, let me write it down here. If I have 100 and I want to go backwards to 0, so subtract 100, I would be at 1500, and I would go backwards 1200, which would put me at 300. Really good. Your y-intercept is when x is 0. 0, 300. Nice job. There's other ways you can do it. You could have used point slope form. You could have said, hey, well, here's a coordinate. That's an xy coordinate. So if x is 100 and y is 1500, and I know my slope is 12, I could use that equation y minus y1 equals m times x minus x1. And when I put everything in there, if I put y1 in and x1 in, that gives me y minus 1500 equals 12 times x minus 100. And then simplify, I get y minus 1500 equals 12x minus, or plus 1200. No, that's minus 1200. Excuse me. And then add 1500, I get y equals 12x plus 300, which still gives me a slope and a y-intercept there. That's my equation, though. So if one equation is the 10x plus 600, the other equation is 12x plus 300, we'll call that y sub 2. The cost of Lakeview, we take that, we use substitution. If y equals y, we could say 12x plus 300 equals 10x plus 600. Okay, we're just using substitution, saying this y equals that y. So therefore this equals that. Who charges less per student? Sunview. How much less? Yeah, $2. Sunview charges 10, they charge 12. Okay. And so if we find out number of students that will make it the same, subtract the 10x on each side, you get 600 equals 2x plus 300. Subtract 300 over, you get x. 2x equals 300. And then divide by 2, you get x equals 150 students. Okay, that's a lot of students, man. Any questions? It's quite in detail. Some of you are like, that was a lot of algebra. That's like a couple chapters of algebra right there. Applying all that. Okay? All right, fun stuff now. I want you to take and look at your graphing calculator. If you'll take that out, we're going to use it for monitoring progress problem 3. Okay? There are a couple things we need to do to begin with. First, you'll want a place where you're taking notes for your graphing calculator. All right, so a special place in your binder that you can continually reference back to, because we'll add to it all the time. That's good. So if you have a place like in the back of your binder where you can just keep inserting pages for special to your graphing calculator, that'll be helpful to you. Okay, first thing we need to do is we are going to reset our memory. So you want to go to second plus 7, 1, 2. I'll go through that again. Okay, second plus is memory. 7 is reset. 1 is all RAM. 2 is reset. Now that may clear programs if you have some amazing programs on there that you've written. But Okay? Make sure you back that stuff up. All right? Next thing. For those of you that are worried about different plots being on and different lists and stuff, there's other ways to do that. I'm not going to go into that right now, but I do want you to turn on diagnostic. Okay, so by the way, if you're keeping notes, reset memory, second plus 712. We'll just kind of put the order here. Second plus 712. Those are our options. Now, if you have a different calculator and it's a bit different order, I don't think it is in any of these, but okay. All right, I want you to turn your diagnostic on. Now, I'll tell you what that means here in a minute when we do this problem, but for what we're doing, you need to go to your catalog. Your catalog is second 0. Okay? So second 0. And then you'll notice when I push catalog, at the top right hand, if you have one of these colored calculators, at the top right hand corner, there's a little A that went on. That means my alpha is now activated. This key right here has been activated because of that little A up there. That automatically happens when you go into the catalog. So if I want that A to disappear, I got to push alpha again, and it disappears. Okay, so if I push alpha again, now it's back on. And I want it on because I want to go down to where I have diagnostic. So I have alpha, I'm just going to find the letter D in green. Well, it's green on mine. So D is where matrix is. So I'm going to select this key because it has the D, and it's going to skip me all the way down to D. And then I'm going to scroll down, just use my down arrow, and find diagnostic on. Right there. And I'm going to select enter. And it says diagnostic on, and it's just waiting. So I'm going to hit enter again. And it says done. So diagnostic. You have to hit enter twice. So if I'm taking my notes, remember diagnostic on, enter, and on my calculator was enter twice, so I hit it twice. Okay? Now you'll like, wow, look what it did. It didn't really do anything that you can see yet. But you will see it here in a minute. Okay? So, next thing, we're going to take some notes on how to create a scatter plot. To create a scatter plot, so let's put two different sets of notes. Scatter plot. We are going to follow these steps. First, you need to identify what you are going to put in your scatter plot. This is what I'm putting in. This is going to be my X. This is going to be my Y, which I will call list 1 for X and list 2 for Y. Okay? So, what I'm going to do is on my calculator, I'm going to find the button that says Stat. I'm going to push Stat. And then I'm going to select option 1, which is Edit. Find the button that says Stat, and then select option 1, which is Edit. So those of you like doing other things right now, in a second you are going to, if not already, you're lost. Stat, Edit. And now, under list 1, you're listing all your X's. And list 2, you're listing all your Y's. So list 1, 33, enter. 25, enter. Kind of like a little spreadsheet. And then to scroll over to list 2, you just arrow over. Okay, so you enter your list. I'm just copying those from here. Okay, once you're done, I want you to quit. So just second mode. That brings you back to that screen. Second mode. Brings you back to that screen. So once you're there, set your calculators down so I know you're there. Okay. So from that point, we are now going to use our scatter plot key. So we're going to go second y equals. I'm going to just kind of draw a line there because that's back to home. Second y equals, which brings me to scatter plot. Okay? You'll notice in that scatter plot display, it says plot 1, plot 2, plot 3, and so on. It says they're all off right now. Well, we want plot 1 on. So what I'm going to do is select enter, and that's going to bring me into plot 1. And we're going to turn that on by pushing enter. Okay. You select it. Now it's highlighted on. And you'll notice other things on here. It asks like what type of graph you want. What list you want to use. Notice, remember we put our x values in list 1 and the y values in list 2. So it's already set. You can choose what color you want and what you want, or at least on this one you can, and what you want your point to look like. But from there we're good. Okay? Yes? Yeah. Second y equals? Yep. Okay? And so now you want to graph it. So hit graph. And you'll see an amazing picture of nothing. You're like, awesome. That's nothing. Okay, well that's not really what you want. You want to be able to see what you plotted. However, remember, this stuff's not on your standard viewing window. So what we're going to do is we're going to use a zoom feature. Stay with me. We go zoom. Now there are a lot of options under zoom, and a lot of you will just zoom out or zoom in. We want to zoom to our statistics, which is which one? Zoom 9, which is stat. When we hit zoom 9 or just option 9, it shows our picture. There's our stat plot. Yes? Invalid dim error? Dimension mismatch could mean a few things. If you have a dimension error right now, go to y equals and make sure none of these plots are turned on. So if you have anything in your y equals menu, it could give you that. If that's okay, if you're like, no, everything's good there, then make sure only plot 1 is highlighted up there. If that's good, then go back to stat and look at edit and make sure you have the same number of x and y values here and nothing else. Otherwise, the dimensions are different. And then if it's still not working, I have to come over and help you, Kai. You have to follow along with someone else. Okay. The next thing, after we have that, what I want to do is get a line of best fit. The way we're going to do that, I'm going to kind of change this up now. I'm going to add some notes here. Line of best fit. Or trend line. Okay, so once I have all of that, what I'm going to do is I am going to go to stat. So select stat again. You're going to arrow over, one arrow over to calc. And you are trying to calculate linear regression, which is the line of best fit. Linear regression, option 4. Okay, so option 4, linear regression. And you get here, and then depending on which calculator you have, may give you a different screen, but it'll all get you the same place. Just keep hitting enter until you see an equation. Okay, enter until you get to the equation. That's the equation. Okay? So now if your equation doesn't match that, there's a chance you just had a different value in for x and y, or maybe I did, and I didn't check my list well enough. If it doesn't match perfectly, no freaking out right now. Just follow with us and we'll be good. Okay? Later on, if it didn't match, would be a problem. But for now, my actual equation of this line, of this data, for the line of best fit is y equals, and if I'm rounding to the nearest hundredth, y equals a, which in this case is 3.05, x plus b, which is 63.53. That is my linear equation, right? ax plus b, a is 3.05, b, that's mine. Now, if one of your points are messed up, that might be a problem. Please also note what r squared says here. R squared is 0.969. That means I'm very, 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 very close to 1. The closer I am to 1, the better match it is. In other words, if it was a perfect straight line, that r squared would say 1. That would mean it's perfectly linear. We know that when I look at this picture, that is not perfectly linear. It's very close, but it's not perfect. It has a strong positive correlation. But it's very close to it. Okay? Okay, 0.969. That's what the diagnostic tool is doing. So if you didn't turn diagnostic on, you wouldn't see r squared or r. The last thing I want to do is actually get the line into my graph. So I need to go back to y equals now. And I need to select VARS, V-A-R-S, this button right here. And under VARS, I need to go down to option 5, which is statistics. And under option 5, I need to arrow over twice to equation. Evan, how you doing there? You doing any other stuff? Arrow over twice to equation and select option 1, which is regression equation, R-E-G-Q. Yeah, and it's going to give you a big mess when you do that. What it did is it put all this stuff without it rounded to a certain number, but it put all that in. And now if you hit graph, it'll show the line of best fit in there as well. Now, the benefit of doing that is you can now, because you have a line in there, pay attention, we're almost done. Because you now have a line in there, you could go to your table feature, which is second graph, and make predictions based upon that data. So like if it says predict when it's 40 centimeters long, we could scroll down to 40. It's going to take forever here. Okay, there's another way to do this, but I don't want to get into that. But I could scroll all the way down to 40 and find out the height of the person when it's 40 units long. Now if it's still reliable, because I'm assuming this isn't going to be reliable data after a certain point, the height of that person would be 185 centimeters. We make that prediction based upon that line of best fit. Okay? All right. Any questions? I'm sure you have some questions. But hey, that's all online. Okay, or it will be. Now, your assignment that I'm about to give you is due on. So the assignment I'm about to give is due on Thursday. So remember that, so you don't have to have it done tomorrow. All right, if I could find my assignments, there they are. All right, and it is not on your quiz tomorrow. Number 1 is to prepare for quiz.